Here we just have one of those sensors that came out of like a heating element. This could be in your oven. This could be in a lot of different type of machinery, your dryer. And if you look here, they'll usually have a temperature rating. I believe this one's 275. So 275 degrees. At 275 degrees, that's the rating of this one. At 275 degrees, it'll become open and it'll shut down the circuit. It's essentially a safety circuit. So we'll go ahead and just show you that there's going to be continuity when there's no extreme heat. You could test this by throwing it in your oven if that's something you wanted to do. We're going to put our meter, it can be on ohms or it can be on continuity. I'm going to put it on continuity just so that you know that it is, so it'll make the buzz. And you can see the reading there as well. Pretty low, 0.3, 0.4 range. So that's a good sensor. If the sensor was bad, it would always be open, meaning that there would be always a high resistance, which you may see in some of your products or some of your items. I've actually never had one of these personally go bad in my house or in any of the products that I use. This one comes from an extra one that I've taken out. You can also test LEDs or diodes. LEDs are also diodes. They're light emitting diodes. You can test the diode. There's a diode setting on this unit. Most units do have a diode. There's a couple things to note about diodes, and I'll show you that when we get to it. But you can test this for resistance. You can also see these are both bad, but if you have a good one, if you put it on diode mode and you have your probes connected correctly, it'll actually light it up for the most part. Not all of them. There are some that is not true about, but most of them do. So what you're going to do is you're going to go ahead and pick up your meter, and if you look right here, you'll see an arrow with a line. That is the one that you're looking for. So let's go ahead and spin it over. If you go on this particular unit, you start out in ohms, so you have to hit select until you get the diode up here. Some of them you don't have to do that, but this one you do. So what you can do is, if these were good diodes and you have the probes right, go ahead and just bend this to make it easier to do this reading. You don't have to do this. If I was to set it up on a holder, one of my holders, it'd be a lot easier. But we're going to go ahead and just do it this way so that you can kind of see what's going on here. As you can see here, the meter is deflecting, saying there is some resistance. There is something going on here. So what I'm going to do is, the voltage is very low when you do this, so it's not dangerous necessarily for you to do this, but don't touch both probes. As you can see here, it has a diode reading of 0.13 volts. Pretty low voltage. We'll check the other way just so you can see what it looks like. And this one's showing 0.13 the other way. Let's check out the red one. And as you see, it didn't light up. The red one will not light up either. Again, I'm just bending these to make it a little easier to hold. A lot of times I'll put on my clamps, but most people don't have those at home, so I'm not going to show that. As you can see here, you're looking at 2.6 volts. The LED is lit up. You can see that one. I was mistaken. This one still is a bad LED. It's not very bright. I think there's some internal resistance that has changed. But as you see, if you have the correct lead and probe together, it will light up. Let's check the other side. And the other side, you're getting an overload. So the way diodes work, there's a reason why they have an arrow in a block. So the way that diodes work is your forward voltage, so your positive voltage in this case, needs to come from the arrow towards the line. So what happens is you have enough, if the voltage is high enough, or let's say the voltage is correct, that's probably a better way to say it. What will happen is it'll overcome the diode and allow electricity to flow through it, or current to flow through it, because that's technically what it is. If you have it backwards, So positive on the line side and you're negative on the arrow side, what will happen is you won't get any current flow through because the way the internal system is within a diode. That's both rectifier diodes or LED diodes. Rectifier diodes, you'll see those. Those are primarily used in AC to DC converters. I've built a few of those over my time. Specifically to run like a 9 volt that I can plug up to your regular AC and run 9 volt. And I know that you can buy what they call wall warts from Walmart and just use those. However, they tend to be fairly dirty. And when you're doing audio specifically, like guitar effects or amplifiers, things of that nature, you want your sound, you want your power to be clean, because that'll actually make your sound come out cleaner. And I should say it more, not cleaner, but the way that you want it to be heard. So yeah, those are just some ideas of what you could do with diodes. I have a rectifier diode somewhere, but these are the same idea. It just prevents electricity going one way. And so what that means is you can create, like I was saying a second ago, power supply. You'll create what's called like a bridge rectifier or half wave, full wave rectifiers. Those are bridges. And what it does is it takes part of the AC sine wave in and it allows you to filter out to make DC. So that's actually how your phone charger or any AC to DC really works, is that way. Which is just kind of good to know if you're ever building something of that nature. I have a big power supply, a big AC to DC power supply that I bought that I use for like bench testing. In theory, I could have just done the same thing with the one I built, but this one has much higher amperage. I was working with about 1 to 2 amps. This will go up to about 10 amps. Your wall socket typically has anywhere from 10 to 20 amps available. Could be a little less. Typically is not much more than that, but it is something to think about.